So I hear you were sick the last couple of days.
I was, yes, sir.
Did you not go to school then?
I haven't been to school since Monday. Well, I didn't go Monday, but yeah, I have.
Okay.
I've been out.
All right.
Planning
Have
to
you
go
been-
back tomorrow. Feeling a little better, so
Oh, good. Have you been able to get your assignments from school?
I have. I've been working on them today. Look, I haven't had too many, so that's pretty good.
That is good. All right. So before we move on with what the new stuff is, your mom mentioned you had practiced some old problems.
I did.
Do you have those with you?
I can get those. Yes, sir. All right, let's see. So I know you gave me 3 from last phone call.
I did.
done those. Let's see here. It's not in. Wait, yeah, that's it. I think that's it. Okay, I guess we can go over those.
Okay.
Let's see what page we want.
116.
116. Okay. So let's see. So 21. Let's see. Oh wait, it's 20. Okay, I'm on the wrong thing. There we go. Okay.
There it is. Okay.
So 21. Let's see. I got x equals 2/3 and y equals -6.
Yep.
And it is consistent.
Did you? IC stands for independent system, right? Okay.
Oh, independent consistent. Yeah, I put IC.
Did you solve by substitution or elimination?
Substitution?
For which
Yeah, I
one?
think so. Yeah. No, yeah.
Did you show your work?
I did.
Did you substitute? Thank you. Did you substitute for y or for x?
Let's see, what did I do? I think I did Y, it looks like.
Of the first one or the second one?
The first problem.
So you should have gotten y equal 3x minus 8.
I got, yeah.
And then you substitute that in. So then you had 6x plus 3x minus 8. So then you had 9x minus 8 equals -2. So you had 9x equals 6.
6, yeah.
Divide both sides by 9. Then so you get 6 over 9, which will give you 2/3.
2/3, yes, sir.
Okay. And then when you plug that back in, 3 times 2/3 is 2. And then 2 minus y equals 8. So then you get negative y equals 6. And then y equals -6.
Yeah.
Very good. Okay. And you also did 23?
23, yes, I did. That was no solution. And
Why
it's
is that?
inconsistent.
How is that no solution?
Oh, because you both have the same x values.
They don't.
No? 4x. Oh, wait a minute. It's not 4x and 4x.
Well,
They-
if you
they
were
cancel.
to put the x's on the same side, you'd have -4x.
Okay.
So you have -4x minus y, -4x plus y, and 4x minus y. And so the reason that makes it inconsistent is so here you have 4x minus y equals -3, and then you also had y equals 4x plus 6. Well, if we were to write it x on the same side, we get -4x minus 4x, and now we have a new system of 4x minus y equals -3, and -4x plus y equals 6. And if we were to solve this by elimination, when you add them together, what's 4x minus 4x?
X, 0, nothing.
0. What's -y plus y?
0.
0. And then 6 minus 3?
-3.
Right.
Just
so you end up with 0 equals 3, and that's not true.
No.
Because you ended up with a false statement, the answer is
No solution. Okay.
Yeah.
There we go.
All right, and then I asked you to do one more. Which one was that?
25.
Excuse me?
25.
25. Okay. What do you have for 25?
Let's see, what do I have for 25? It's kind of weird, the answer I got. Is it just, could it be just like x equals all real numbers?
Sort of. What happened? What did you get?
So I know I got 5/3 and 2/3 or negative 2/3, but it's like I got the same if they were like both for x.
So did you try to solve by substitution or elimination?
I think I did. Let's see. I did substitution. Yeah, I think so.
You
Yeah, substitution.
Okay. We can do that, but I'm just gonna go ahead and put these where they belong. Because I notice as a math teacher that I have the exact same coefficients with the same variables. So then we have 2x plus 3y equals 5, and I have 2x plus 3y equals 5. See that?
I do.
You see how when I moved it, I now have the same exact problems?
Yes, sir. Oh, it makes sense.
So if I subtract them, I end up with 0 equals 0. Is that a true statement?
It is.
That means this is dependent consistent.
Dependent consistent. Yes,
Okay,
I got that part.
dependent consistent must be written in the form y equals mx plus b.
Yes.
So with this one was already practically there. It's going to divide by 3.
Yes, then you get what?
So then you would end up
that's
with
how I got
equals
5/3.
5 over 3 minus 2 over 3x, but I need to rearrange it to where it's slope-intercept form. So we get y equals negative 2/3 x plus 5 over 3.
Okay, I just had them flipped. All right, that makes sense.
Yeah, anytime you have a true statement like this, we get 0 equals 0, it needs to be written in the slope-intercept form. Has to be for dependent consistent. All right, and then did you do any problems on your own?
I did. Let's see what page. There we go. So I did 120.
You did page 120?
Yes.
Is this homework or is this something you did on your own?
Oh, this is what I did on my own.
Because page 120, we had worked on some of these last week, right?
Oh, we might have, but I didn't. Oh, maybe.
Because these
I
are,
just did them again, I guess.
I believe that we had started working on, no, we didn't do 3.3 yet, just kidding.
Okay, yeah.
Okay, so you worked ahead instead of going back and doing 3.1?
Yeah, I guess I did.
Okay. All right, what numbers did you do?
I did one. I did the odds going up to 9 so I could check my answers.
Okay, for number 1, find two numbers whose sum is 91 and whose difference is 17.
So I first you have to do what? You can do x plus y equals 91. Then you can do x minus y equals 17. That's kind of how I put it. It's like a equation. Yeah, there we go.
So you did x plus y equals 91 and x minus y is 17?
Yes, because you're subtracting or you're adding two numbers, and you're subtracting two numbers.
So x plus y equals 91 and x minus y equals 17. So how would you solve that?
Well, you could put it in the y-intercept form.
Well, yes. Remember, there's more than one.
Oh yeah, you can. Can you add them together?
Yeah, there's more than one way to solve these. You were given the options to do substitution or elimination. If they're set up and you have opposite signs with the same coefficient, it makes sense to just do it by elimination.
Okay, there we go.
And you end up with x
2x.
equals what is that? 108?
Hold up, 91 plus 7. Oh, wait a minute. 91 plus 17. Think so. 108.
And then when you get x by itself,
108 divided by 2. Isn't it? Let's see. 216.
you multiply by 2.
Oh yeah, my fault. Yeah. All right, 108 divided by 2. There we go. We get 54 as
right. So now we have 54 plus y equals 91. To get y by itself, you subtract
y or subtract 54. Yeah.
And y equals
37.
37. Good job. So that's your answer. X is 54, y is 37. Yep. Okay. What about number 3?
Okay, so first we can get let's see, the 10% and turn it into a decimal. So we get like 0.10.
Mm-hmm.
And then we can multiply that times. Wait a minute. Yeah. Wait. Where did I do it?
What's the formula for simple interest?
I just did it. It was so it was your total, or yeah, that's it.
Interest equals principal times rate times time.
Yes.
Do you know the principal for number 3?
10,000.
But that's the principals added together.
Okay, so then, oh well, yeah, we don't. No, we don't. Not yet.
Exactly, right.
So that
But you do know how
Yeah,
much
you
you
do.
got altogether, right?
yes,
Yeah.
he got 650 interest. So we do know that.
And how long was it in the bank?
Let's see, 1 year.
Right, so time is 1. Right, and
Yes.
you don't know your principal.
No, not yet.
Okay, for the second problem, or for the second one, what is the rate of return?
5%. So 0.005.
0.05.
0.05. Yeah.
How long was it in the bank?
1 year.
1 year, and that was a separate amount he did, right?
Yes.
Yes. Okay. And so we know that if we were to add these together, okay, they're going to give you how much?
Let's see what.
How much interest did he make in? Because these are both interest,
Oh yeah,
right?
650.
650. So you now have 0.10x plus 0.05y equals 650. Okay? And
Yes.
between his two different principles, which are x and y, how much did he invest altogether?
10,000.
10,000. Yep. At this point, you now have a system of equations. You've got x plus y equals 10,000 and 0.10x plus 0.05y equals 650. And now you can solve using whatever method of your choice. And what did you get for x?
3,000 at 10%.
Okay. And what did you get for y then?
7K or 7,000 5%.
Okay. Yeah. So did you solve this by substitution or elimination?
Elimination.
So did you multiply, what did you multiply which one did you multiply stuff by?
The 0.10, I think, x.
What did you multiply by?
2. I think. Let me check.
Why? Because if you multiplied it by 2, it's not going to give you the same coefficient.
Wait, no, I did not do that. When you multiply the times 10,000, wait a minute. 10,000, I thought I divided.
Well, there's only 2 ways to solve a system that you know of.
When you have, yeah,
Well,
elimination.
technically there's 3, but we're not graphing this. So you're either going to do substitution or elimination. So if you did elimination, you have to have the same coefficient for each variable. So you either have to have the x with a 0.10 or the x with a 1.
Yeah.
Or the y with 5. Which one would you do?
So let's see, if you multiply x, so this x times 0.10x, you'll just
Okay, so
get.
you multiplied the bottom one by 0.10.
Yes, and then you'll get
0.10x plus
plus
0.10y equals 100.
Yeah. Yes, let's see.
Yeah, because it moves those places 2 places.
Yes.
All right, and then you have to add or subtract them.
So the top and the bottom we added, I think.
Well, if we
Yes.
added them, they're all positive. So if we add them, we're not going to get rid of x or y at all.
Oh wait, so what is that? What is it? 0.5y.
Well, Sam, if we add them together, nothing will get eliminated.
True. So wait. Okay, yeah. So we subtract, then we just get let's see, what's 0.5 y plus
Negative
or minus
0.05 y
0.5 y, and then
equals,
650 minus 100 is 550.
yes. Oops,
So we could
550. I
do-
ran out of room.
Uh-huh.
Right, so we've got negative 0.05 y equals 550. Is that right?
No.
Because we're going to end up with a negative number. So y is going to give us something weird. So maybe we shouldn't have multiplied it by a decimal.
Okay, then let's see. We shouldn't multiply it by 10,000. That's too much.
Oh, sorry. It was. It's not 100, is it? It's 1,000.
Yeah, it was 1,000. I typed it in. But let's see.
Yep.
But still,
So,
wouldn't
so then it would be
that's-
650 minus 1,000. Which
Alright,
so you have negative 0.05 y equals negative 350,
negative 350. Let's see.
right?
What are we doing? 650 minus 1,000?
Yeah, that's negative 350. And then when you divide by negative 0.5, you end up with 7,000, positive 7,000.
Positive 7,000. Oh, wait. 7,000. Oh, yeah. That's
350
right.
divided by
Yeah.
0.05.
Yeah,
Yeah.
7,000 at
Y would
5%.
equal
So, yeah.
7,000. And at that point, we have what we need.
Yeah.
All right. So did you show your work on these?
Yeah.
All right.
It's in my book right there.
Okay.
I probably can't see it, but.
I cannot because I'm not looking at your screen.
Oh.
Okay. And then you did 2 other ones?
Actually, yes, I did 7 and 5.
7 and 5. Okay. We'll come back to those ones. Okay. So for now, let's look at what your assignments are so we can catch you up before you get back to school tomorrow.
Yes. Okay, let's check. Uh-oh. Okay, so I think we just had a couple problems. On 3 point. Wait, well, so we just had I was supposed to take a quiz Monday, but I was out.
Over what?
3.3.
Which is what we just did. Okay.
Yes.
It's where
Wait,
you set up- it's where
I
you set
think
up
it's
the systems and then solve them.
3.3. I think it was 3.3. Quiz. I'm trying to find it. 3.3. Yes. Yeah, it was 3.3. Okay.
Okay. Yeah. So that
So
you're
my
taking the quiz tomorrow.
yes. So my newest assignment. Okay, here we go. So I think let's see, 1.2. I think we're starting 3.4. So
3.4. 3.4 is graphing systems with inequalities.
okay,
So this is where you're going to have to make sure you put everything in slope-intercept form, or make sure you're familiar with absolute value graphs as well.
So what did page 126 to 127, 2, 4, 30, 32, and then 6 to 28 on graph paper, and 41 to 50. So I think it's all of it, just some in the journal and some on graph paper.
Wait, what do you have to do? What numbers?
Number 2, number 4 on 126, and then 6 through 28 would be on graph paper.
Right.
And then 30 to 32 regular in the journal, and then 41 through 50
Okay.
is the
So,
journal. Yeah.
All right. Do you have that written down, or can you look at that and look at your book at the same time?
Yeah, I can do that.
Okay, how much of this have you already done?
Write it down. I haven't started.
Okay, perfect. All right. So the first couple ones are easy. So we've got what page is this on? 126. It's quite convenient that I have the same book as you.
Yes, very.
So number 2, it says for each system, determine whether the given order pair is a solution. Remember when it comes to inequalities, what's the only thing that's different when solving inequalities versus solving equations?
There's two or more systems.
Well, no, this is when it comes to solving equations versus solving inequalities,
Oh, okay, yeah. There's the signs, the inequality signs, the greater
Yes,
than,
sir.
equal to, all that stuff.
Yeah, so the only rule that's different is if you multiply or divide both sides by a negative, then you swap the sign. Greater than becomes
Yes.
less than, and less than becomes
If you multiply or divide, right?
both sides by negative, yes.
Yes.
Okay. Number 2 and 4 are simple. You're just going to substitute and solve. So for number 2, you have 2x plus 5y is greater than negative 10. So 2x plus 5y is greater than or equal to negative 10. And you also have x minus 7y is less than or equal to 6. And you were told the solution is negative 7, 0. In order for this to work, it has to be true for both equations. All right, so for the first one, we're going to substitute. What's the value of x?
2. Right?
Um,
Sorry. Negative 7. Negative 7.
Yep. And what's the value of y?
0.
0 is greater than or equal to negative 10. What's 2 times negative 7?
Negative 14.
And what is 5 times 0?
0.
0. Is negative 14 greater than or equal to negative 10?
Greater than or equal to? No.
No, it's not. So is this a solution to the problem?
No.
Nope.
So you just write no.
Number 4, you have x plus 3y is less than or equal to negative 7, as well as x is less than or equal to, or just less than 2y plus 6. And what did they say the solution might have been for this problem system?
Negative 4 is x and negative 1 is y.
Right. So we're simply going to substitute and solve. So for the first system, all right, how am I going to rewrite it?
Let's see. Negative 4 plus 3y is less than or equal to negative 7.
Well, for the x, you already substituted the negative 4. What did I have to substitute for y?
Oh, sorry. Negative 1. So it would be negative 3, basically.
All right, so 4 times, so what's 3 times negative 1?
3 or negative 3.
So I have negative 4 plus negative 3. What's that give you?
Negative 7.
Yep. Is negative 7 less than or equal to negative 7?
Yeah.
All right, so it's a solution for the first one. But remember, in order for it to work, it must be a
Has to be
solution
for
for
both
both of them.
Yes.
All right, so for the second one, how am I going to rewrite it?
Negative 4 is less than 2 times negative 1 plus 6. So,
Okay.
2.
Right.
So negative 2. So, yeah. Negative 2 plus 6 is positive 4.
Is negative 4 less than positive 4?
No. Oh, wait. Yeah.
Yes, it is.
Sorry,
All right,
yeah.
so is this a solution?
Yes.
Awesome. All right. Okay, after 2 and 4, what else do you have to do?
I really just wrote it down. Oh, yeah, here we go. So, for in the journal, we just have to do 30 to 32.
30 to 2.
And then all the rest will graph. All right, 30.
Okay, so you weren't in school for this, right?
No.
Okay, so what I'm going to do is I'm going to go back and show you the lesson. So that way you're not completely confused with what's going on. Okay, so here, when it comes to graph with inequalities, remember, if it is less than or greater than, it's simply just a dotted line. But if it's greater than or equal to or less than or equal to, then it is a solid line.
Okay.
So for example 1, I have 3x plus y is less than or equal to 4. Okay, so that's why I have a solid line. And I have x plus 3y is less than negative 6. That's why there's a dotted line. And then in order to actually graph these, they must first be converted to slope-intercept form. So y equals mx plus b. So 3x plus y is less than or equal to 4 gets turned into y is less than or equal to 3x, negative 3x plus 4. And x plus 3y is less than negative 6 gets converted into y is less than negative 1/3 x minus 2. So in the slope-intercept form, what stands for the y-intercept?
The straight line.
The b.
Yeah, B.
So y equals mx plus b.
Oh,
So
yeah.
here's the y-intercept. So the first one's going to be at 4, right here. and the other y-intercept is going to be at -2. Right there. See where I drew those dots?
I do.
Okay. And the slope stands for what?
X or M, sorry.
What does it stand for?
A rise over run.
Yep. Which is change in y over change in x.
Change in X.
If your slope is -3, it means it's going to be -3 over 1.
1.
We're going to go down 1, 2, 3, right 1. Boop. Down 1, 2, 3, right 1. Awesome. And then we use a straight edge. And look, it's already connected because it's in a book. Yay. All right. And then for this one, what is the slope for this one?
-1/3.
We're going to go down 1, right 3. All right. So here is where it is. And then I ran out of room. So I'm going to go up 1, left 3. And right there. Use a straight edge to connect it. But since it's just less than, it needs to be a dotted line. Now, both of these are less than. So we're going to shade, we're going to go on the line and move down and shade everything below it.
Yeah.
Same thing. So everything below it. So where they overlap in their shading is the solution to the problem.
Okay.
So anything in here, anything in this little box I created would be a
It's the
solution.
solution.
So if I choose this dot right here,
It's
this
a
is
solution.
2, -1, 2, 3. -2, -3 would work. I could also choose this right here. This is -1, 2, 3, 4, -2. -4, -2 would also work. Anything inside this box would be a solution to this system. Now, does the graph only extend on this box?
No.
No. So anything anything in there here would be a solution. Regardless of what you choose, it will work for this system because it's an inequality.
Yes. Makes
Okay.
sense.
Oops. All right, and then example 2, that's to solve the system. In this instance, when we were to convert them to both slope-intercept form, you're going to see y is less than 3x minus 1 and y is greater than 3x plus 3. These have the same slope, so that means they're parallel. Same slopes. If the slopes are parallel, all right, they equal each other. It's a parallel lines. They also have different y-intercepts, which means they cross the y-axis at different points. But their slopes are exact same. So that means they'll never cross. So since there's no shading that overlaps at all, the answer is an empty set.
Okay.
Because there's
They
nothing
don't-
that
yeah.
works to solve both of these because of the parallel lines.
They don't overlap.
Yep. All right, and this one here, these are absolute value. So remember the absolute value, it's been a while since we did this, but y,
I remember it, yeah.
a, well, I'm going to do absolute value. Y equals the absolute a times the absolute value of x minus h plus k. H moves it left or right. So remember, positive moves left, negative moves right. And k moves it up or down. Up is positive, down is negative.
Yes.
So here, the absolute value of x plus 2, it's going to be a v. It's going to be with a slope of 1. And it's going to move to the left 2. So it started here, and it's a slope of 1 and 1. 1 and 1. So that's where we got our v. And it says y is less than or equal to, which is y is a solid graph. Solid graph. And then we're going to shade everything below. But it's less than. And this one, it's just going to move down 1 because k is -1. So the y-intercept is here, but the slope is still 1 and 1. And then it says everything above. Solid line at above. So right here, everything in here is the solution. This is anything within these little bars to be the solution to the graph. Because that's where the overlapping takes place.
Okay.
You got it?
Got it.
Okay.
So basically it's just graphing, but we already know how to do that stuff.
Yes, but it's just now combining graphs. Instead of
Makes
one
sense.
graph, it's 2 graphs.
Hmm.
All right, Sam, this is a lot. So let's take like a quick, 1-2 minute break.
Okay.
So that way you can, get a chance to collect your thoughts. All right, and then we were going to try to attempt some of your problems. So
Yes.
what have you been doing the last couple of days?
Just laying around watching TV, and if I feel like it, doing a little work.
Have you been eating chicken noodle soup?
I did eat chicken noodle soup yesterday, but today I had a cheeseburger.
Oh, okay. I was gonna say the couple things to avoid when you're sick are dairy and sugar, but
Well, yeah, well, I'm on the feeling better side today.
okay.
Like I think it's mainly just my like throat now and just blah, but yeah,
We had
it's
an away
it's
game
not
yesterday.
stomach problem. So yeah.
Yeah, well, I'm glad you're feeling better. We had an away game yesterday, and it was 3 hours away. So we had to leave school.
Whoa.
We left school at noon, and I had to drive through the mountains in the bus. And at one point, going uphill, like the bus like couldn't handle it, so it dropped down to 40 miles per hour, and I'm flooring it. And the bus is just like barely creeping up. Anyway,
Where was
um,
that?
it was in Edinburgh, Virginia, at a Christian
Okay.
school called Valley Christian School. Anyway, so we were there, and then we lost both games. Whatever, it is what it is. I only have 5 guys on my basketball team, and they had 15, so like they constantly had in fresh guys. So anyway, the girls lost too, but our girls, it's their first year playing basketball in 6 or 7 years, so it's been a while. Anyway, we had to drive back 3 hours after the game.
Yeah, no, yeah. I
So
mean, if
we pulled into the school parking lot at 10:15 last night.
yeah, if y'all won, that's a different story. But
Yeah.
6 hours round trip just to lose.
Yes, I know. It was rough. And then this morning, everyone's coming into school and they're dragging their feet and
Yeah.
they're all tired all day. And I'm like, I'm sorry. But the principal rode the bus. And he's like, if you don't come tomorrow, you don't go to any future games. He's like, I know it's late. I know it's hard. He's like, but games are a privilege. And if you don't come to school tomorrow because you're tired, you're not going to any more away games. I'm like, we'll be there.
Yeah, we'll be there. Yeah.
And I'm telling you, I was struggling today. Like, I was trying so hard to be perky and act like everything was fine.
Yeah, that's when you need a coffee with about 20 shots of espresso.
I had an energy vitamin water this morning,
Yeah.
so and I was fine up until about last hour. And then I was like, all right, my patience is gone.
Yeah,
These kids better be good.
that drive back that was probably the worst.
Oh, I had
What's
I had earbuds in, I had an audiobook going, but like those
Yeah.
kids were crazy like every 20 minutes. And then I kept the bus really warm and it was dark, so they kept falling asleep. But every time the principal needed something or kid needed something, I had to turn the lights on, so they kept waking up. And then of course when they woke up, they're all like, yeah. I'm like, okay.
Yeah, that's like most of the time if you have like a long bus ride to where you play, you're not gonna do good. Like it depends. I think our farthest school away is like an hour and 45 minutes. Sometimes when we get there, we're feeling like,
Yeah,
don't
I
have to
know.
drive
I
as
knew a
far.
long drive on a Tuesday was gonna be rough for them getting there, but we had 30 minutes to warm up. But like, yeah, it was a lot. So anyway, but it's a memory, and the kids are happy about it.
Yeah.
All right,
Wow.
let's spend the last couple of minutes going over your homework here.
Okay.
I
Thank
think I
you,
successfully
Party.
distracted you from the crazy graphs. All right, so let's look back at your homework on page 127 here. Now so since you see 2 lines, you're gonna have to create a system using inequalities. So you don't have to do 29, right?
No, just 30 and 32.
So 30 and 32. 30, you notice you got 2 lines here. So we're going to look at the easiest one first, and that is this one. What kind of equation is for a slanted line?
Wait a minute. Let's see. For a slanted line?
Yeah, for just a regular line. Like that.
Oh yeah. It's less than or equal to.
Well, yes, but what's the equation of the line? It crosses the y-axis and it has a slope.
Oh, negative.
You're getting it. I need the actual equation, like y equals something.
Oh, okay, yeah. Y is equals mx plus b.
There we go. Y equals mx plus b. Awesome. Okay. All right, so we need to figure out b. So where does it cross the y-axis?
Y-axis at 2. Yeah, 2.
Crosses it at 2. Okay. So we know that b equals 2. All right. And what's the slope?
Let's see. 1 down to a right 1. So
all right. So the slope is -2 over 1.
-2 1.
All right. And is this above or below the line where it got graphed?
Below.
Below. So it's going to be less than. And is it a solid or dotted line?
Solid.
So less than or equal to.
Yes.
So we're going to end up with y is less than or equal to -2x plus 2. Cool. We got that done. All right. Now, what is the graph that's going to make a V? What is that?
Oh, that's an absolute value.
Right. So y equals the absolute value of x. Okay. However, did the vertex move?
Yes.
The vertex is here. So it moved, where did it move to?
Was that negative, or no, 1, -3, I think?
Right, so it moved right one. So if I want to do that, is that inside or if it moves left or right, is it inside or outside the absolute value?
Um, outside.
Left and
No,
right is inside.
oh, left or right's inside of the downside.
So if
Okay.
it moved to one, it means it's a positive or negative.
Negative.
Right, x minus one. Okay, and then it moved down.
So that's what? -3. Yeah.
Yep. Okay, and then and then this is greater than or less than? Did you shade above or below the absolute value?
Above, so it's
Above.
greater than.
So
Or
y
equal to.
is greater than or equal to the absolute value of x minus 1 minus 3.
Yes.
So for number 30, that's how you would do that one.
Okay.
You have to create
That's not that
you have
bad.
to create two separate equations of a line, and then notice if it's solid or dotted, greater than or less than.
Yeah.
Okay. We should be able to leave that on the screen to be able to do number 32. Number 32, what do you notice about both types of these graphs? Tell me everything you know.
They're gonna be less than or equal to.
Are they going to be equal to?
Or no. Oh, sorry. I meant less than or greater than.
Right. No, because there's no solid line, so we're not going to underline anything.
Yeah, just less than or greater than.
Uh-huh. Also, are either of these going to be absolute value?
No.
What are they both going to be in the form of?
What inequality?
Well,
Yeah.
they're both, it's equation of the line, which is going to be y equals mx plus b.
Yes.
All right. So that's what we got to work with here. All right. So let's look at the first line here that I can easily see here. What's the y-intercept?
The y 1 to 3.
So b equals 3. All right. And then what's the slope?
Up 1 over 3.
So your slope is 1 over 3.
3.
So what would be the equation of the line there?
Y equals 1 over 3.
It's an inequality, so it's not going to be equal.
Yes. Let's see. That is y is less than 1 over 3 x plus 3.
Good job. All right. Hopefully you have your book in front of you because I can't move my screen. Where does it cross the y-axis for the second one?
On the y-axis.
Yeah.
Oh yeah. I can see that. I think let's see. 1, 2, 3, 4, 5. It looks like.
Positive or negative?
-5. Yeah.
Yep. And then can you tell your slope?
Let's 3 over 1.
Yep, 3 over 1. So how would I write that as the equation line? Did it shade above or below?
Let's see, above. So y is greater than 3 over 1 x minus 5.
Okay. Now, did you also notice that the shading doesn't go over here? You notice how there's no shading over here?
Yes.
Why do you think that is?
Ooh.
Do you see where it stops?
Yes.
Where does it stop?
Oh, it stops in between the y and the x-axis. 0.
Yeah.
It stops at 0, yeah.
It stops on the x-axis and the y-axis, right?
Yes.
So we're gonna have two more restrictions.
Okay, so it's
so the x-axis is gonna be part of it. So is it above or below the x-axis?
above.
And is the x-axis solid?
Yeah.
Yeah, so x is greater than 0. All right, and then for the y-axis, is it to the right or the left?
It is, well, to the right.
To the right. So that means it's also going to be greater than or equal to, oh, I think I read that wrong. X is above, y is.
It's below.
Yeah, x is to the right, y is above. Yeah, we're good. Okay, y is also greater than or equal to 0. Because in quadrant 1. So this one has 4 inequalities.
Okay.
So you've got the 2 for the line, and then you also have the 2 for the axis as well. That's why the shading stopped at the origin.
I see that.
Yeah. You catch that?
I did.
Okay, good. That's going to be important to note because you're going to see that on a quiz. Like it will happen. So when you have equations, it's not going to be just 2. Sometimes there could be 4. So pay attention to where that shading is.
Yeah, that was a little where I was like, what?
Okay, and then when you have to do the graphing on your graph paper, make sure you convert it into a form you know how to do. For instance, like all of these ones, like 5 through 16, not all of them are in slope-intercept form. Like 9, 10, 11, and 12 are in standard form. So you have to
Yes,
convert those
you got to put them into
form.
y-intercept.
Yeah, and then also pay attention to the absolute values here. Make sure, remember, if it's inside, positive moves left, negative moves right. And if it's outside, negative moves down, positive moves up.
Yes.
All right. So I think you have what you need to be successful here on your homework, but make sure you stay on top of it. Okay.
Okay.
And as practices go, Sam, you're going to want to practice problems from 3.1, 3.2, and 3.3.
Okay.
Before you go to school tomorrow, take that quiz. I hope you don't take it your first day back, but if you do, you'd be beneficial to practice some of the problems from 3.1 and 3.2.
Okay.
It sounds like you know how to set up the systems, but the solving them is going to be what's going to get you.
Gotcha. Okay.
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 Well, I'm glad you're feeling better, and I hope you can stay healthy all the way through the rest of the week.
Yes, sir. Thank you very much.
My pleasure. You have a great evening. Get some rest, and don't forget to get this homework done before you get there tomorrow. Okay?
Yes, sir.
Okay.
All right. Thank you. Have a good one.
You too.
Bye-bye.